This is another video introducing exponential function. Compared to the previous video, we have 2 to the x and 4 to the x. This time I put a negative 1 in front of the x to see how does that affect the graph. So 2 to the negative x, 4 to the negative x, I want to try a bunch of table value. For the negative x, so when you plug in negative values like negative 2, negative 1, and 0, so the two negatives becomes positive. So 2 squared is 4, 2 to the first power is 2, 2 to the 0 power is 1. And then for 4 to the x, 4 squared 16, 4 to the first power is 4, 4 to the 0 power is 1. Now, in this type of exponential function, what happens when x is positive? So we have 2 to the negative 1, 1 divided by 2 to the first, 1 half. 2 squared, 1 divided by 2 squared, 1 over 4th. 2 to the third, negative 3. Actually, this is a negative 3. 2 to the third power, so that is 1 over 8. All right, and then how about the fourth? So the fourth, we have 4 to the negative 1, so 1 over 4 to the first, a quarter. 4 to the negative 2, 1 over 4 square, 1 over 16, and then 4 to the negative 3, 1 over 4 to the third, this is 64, right? And then each calculation gives you an order pair. X is equals to negative 2, y is 16, negative 1 comma 4, 0 comma 1, 1 comma a quarter, and then 2 comma 1 over 16, and then 3 comma 1 over 64. You can plot these points, connect them to sketch the graph, or you just do the graph on decimal. Decimal, I mentioned this so many times in my video, DES, just look it up on Google. It's a graphing app or website. You can do it for free. You can download the app to your phone. You can do the graphing for free. All right, so let's write the points for the 2 to the negative x. So this is a negative 2 comma 4, negative 1 comma 2, 0 comma 1, 1 comma a half, 2 comma a quarter, and then 3 comma 1 over 8. And then the graph, I already prepared the graph for you. So this one, I also have the points. If you want, I know some of you might want to see the points, right? You got some points. You want to see that on the graph. You have to, on decimal, you need to click the gear. So there is a gear symbol. You click the gear, and then there is a table symbol. You click the table symbol, you can choose some value for x, and then they will display the y values for you. And then they will also show the table values, the points, on the graph, as you can see on the picture. Now, let's do a comparison for the 4 to the negative x and 2 to the negative x. So for the bigger base, I mean 4, I match the color code for you. When x is greater than 0, which is on the left-hand side of the x-axis, the purple function increase very fast as x approaches to negative infinity, way faster than the orange function. So when x is equals to negative 1, we have the purple equals to 4 and the orange is equals to 2. So when x is less than 0, the purple function, the one with a bigger base, goes up much faster compared to the orange function. When x is greater than 0, which on the right-hand side of the y-axis, you can see that the purple function goes down much faster compared to the orange function. When x is equals to 1, the orange function is 0.5, the purple function is 0.25. All right, and then for the domain, for both function, x can be any real numbers, just an exponent. You can plug in anything you like. And then for the range, the curve is above the x-axis. We do not use y equals to 0 because y equals to 0 is a horizontal asymptote. Do you see the green dotted line? It's a horizontal asymptote, y equals to 0. The description is, as x approaches to positive infinity, both function approaches to 0. This 0 means y is equals to 0. And then the arrow means approach. In general, this is an exponential function with a negative exponent, a to the negative x, and then it is a decreasing function. The y-intercept is at 0, comma 1. For the function that we just did, the y-intercept is at 0, comma 1 as well, because when x is equals to 0, any non-zero base raised to the 0 exponent is just equals to 1. And then the horizontal asymptote, this one I put that in a green dashed line. As y approaches to 0, I mean is the horizontal asymptote, HA, horizontal asymptote is y equals to 0. As x approaches to positive infinity, the function approaches to 0. This 0 is y equals to 0, and then the entire function is a decreasing function. Alright, so that is the end of this video. If you like the way I introduce exponential function, give me a thumbs up. Give my channel a subscribe. I truly appreciate your help and support. I will meet you all in the next lesson for more interesting videos. Signing out.